Hello, everyone. Welcome to another live session at the Reactors. Before we get into the session, please take a moment to read our code of conduct. We're all here to learn, so please be respectful of other people's views, understanding of differences, and please be kind and considerate in the way you engage. Today is the second episode of the three-part series of building and working with virtual networks in Azure. And it will be led by Liam and Gwen, both regional cloud advocates at Microsoft. Both of them today will be discussing all about working with your Azure Vnet. As a part of this series, the speakers, Liam and Gwen, are running a Cloud Skills Challenge, which they will be discussing towards the end of the presentation. So please do keep an eye out. With that, I'm now going to hand over to Gwen, who will lead the session, and then Liam will be joining in later. Hi, Gwen.
Hi there. How's it going?
Good. Over to you.
Thank you for that fabulous introduction. Hi, everyone. Everyone in the chat, please do tell me where you're checking in from. Let me bring up my screen here. We're on episode 2 here. I don't know if I hope most of y'all were part of last week's session where we started the series building and working with virtual networks in Azure. Had a couple issues. I was still sick. I'm almost fully recovered, still coughing a little. So if I have to take pauses to drink water and whatnot, yeah, I do apologize for that. But yes, today we're at episode 2 of the series, working within your Azure virtual networks, Liam and myself. And for the agenda, we have about us, quickly, a couple details at the beginning about the series. Then we're going to talk about what is a virtual machine. What is a hypervisor, virtual machine versus containers? I think there's a section on storage a little bit as well. And then demo. First off, about us, myself. My name is Gwen. I'm a cloud advocate here at Microsoft for about 10 months. I'm also a YouTuber. You might be watching this on my YouTube. Big fan of .NET and a big fan of serverless technologies and services and projects and whatnot. And we have Liam. Liam, you want to come on and give us a quick intro
of you? There we go. Hello, everybody. It's so good to be here again. And Gwen, it's amazing to see your sound is working with your screen share this week. So this is going to be a good one. So hello, everybody. My name is Liam Hampton. I am a regional Microsoft Cloud Advocate based here in London in the UK. I'm an open source contributor. Prior to this role as an advocate, I was actually a software engineer. So I've written a lot of Golang, Node.js. I've done some technical blogs, some for the All0 blog as well. For those of you who don't know, they are a security company, kind of owned by Okta. So fantastic as well. Through that, I've become an IoT enthusiast, public speaker, and I am a world traveler. So it's great to be here. And I will let Gwen now take this one away.
Awesome. Thank you, Liam. Alrighty. So like we mentioned, we have sort of a couple of episodes, but we'll dive into that a little bit more. But series goals, we have 2, actually. Understand how virtual networks are built and utilized. And 2, put learned lessons into practice. So we're dividing each session into some theory, which I'm going to try to get through quickly because I know Liam has prepped a great demo for us today. And we try to apply that theory in the demo because it's great to get hands-on. And everything that we do, we make available for all y'all to go ahead and implement as well. So the goals for this episode is 1, to understand what a virtual machine is, and then 2, understand how to interact with a virtual machine in Azure. About the series specifically, last week we had a Bicep template that we sort of walked through, and we talked a little bit about some fundamentals of networking, some fundamentals of Bicep. And we didn't get to deploy it because I was having a technical issue with my audio. But we will deploy that at the beginning of today's demo, and then we'll follow up with the rest of the stuff for the demo. For episode 2, we have working within your virtual network, so that infrastructure already deployed, we're going to work within it with the virtual machines that within it. I know Liam has some cool stuff planned there. And then for the third one, which will be next week, we're going to be sort of locking down the infrastructure, securing it, using more rules and such, things like that, right? And like at the beginning, we mentioned there is a Cloud Skills Challenge. There's already like 250 people participating in that. We've already given out a couple of certification vouchers. People have reached out and have been able to prove that they actually did indeed complete all the modules. We still have a bunch more to give out. So out of everyone, once you do complete it, we'll provide all the links that you need in the chat. Once you do complete it, please do make sure to reach out to us so you can win a voucher 100% for any certification you want to go for. The challenge itself is sort of aimed at the AZ700, but it works for anything, right? And remember, today we are in episode 2, working within your virtual network, right? Like we mentioned, you can get hands-on with all the stuff that we're doing and sort of implement these things on your own. If you're a student, go to aka.ms/A4us. And if you're a professional, you can go to azure.microsoft.com/free. And both of these accounts come with not only free tiers, some Azure services have free tiers all the time, but also credits and such, especially if you're a student. So do take advantage of that, because the best way to learn is to get hands-on, right? All right, so let's get started. Kickstart with our theory for today. Also, if you don't know, that animal is called Bit. He is our mascot, our Azure Advocate mascot. I actually have like a plushie. Liam has one too, but he's over there, so I can't get around. But I think out of all the DevRel mascots out there, I think ours is the cutest, in my opinion. But anyway, let's talk about, what was it saying? Oh, what is a virtual machine? Often you'll see it abbreviated as VM. So a virtual machine is the virtualization or emulation of a computer system, right? And virtual machines is, I don't know about y'all, let me know in the chat. It's probably one of the first services that I ever touched when I was trying to learn like cloud computing. And I remember the first time like SSHing into like a virtual machine that I like had deployed. I was like, oh my goodness, I am in the back end of Azure. You know, because you have your terminal and it's like white letters with black backdrop, and you're like, oh, I'm a hacker man, right? Very cool, right? But anyway, so use cases for virtual machines, building and deploying applications. Yes, nowadays we have containers, we have things like app service. We have these different services that abstract ways that we can deploy and build applications. But, you know, virtual machines, still a great use case for this type of task, right? Testing operating systems / applications. If you need to test a different version of operating systems or applications, you can have a virtual machine that's tailored to those needs and requirements, right? Creating development environments. Yes, if you need to have some sort of maybe a development environment that's smaller than your production or something like soup to down or something like that, you can also use virtual machines for that. Backing up data, you can just attach a bunch of disks, which we're going to talk about storage a little bit later, but a bunch of disks to your virtual machine and just use it as like, you know, for storage and such. And then we have access to legacy software. If you have software that needs to run on a specific operating system, you can have a virtual machine that's on that specific operating system, and then you have access to that. But this is like a pain. I remember being in my sysadmin days, and we had a bunch of virtual machines that were like server 2006, I believe, 2006 R2, or was it 2009? I can't remember. But we couldn't like upgrade them because there was software that had to be on that specific version. It was such a pain. And this was back in like 2017. So you're talking like years of difference between when that operating system was released to like when we were working on it. Absolute pain to work with. But it's still a thing that you can do, right? All right. So why would you want to use virtual machines? That is a good question. But anyway, you know, you used to have like physical servers where you would actually have to rack them. And these still very much exist. I was recently talking to someone, his name is Ignacio. He works with like mainframes and actually like physical things, right? And these things still exist. You know, they have their areas. It could be compliance reasons, security reasons, whatever, but actual physical servers that you have to rack and you have to cable and all these kinds of things. With virtual machines, you have cost savings because you don't have to have like, you have less physical infrastructure to worry about. And speedy, quick to provision. You know, you don't have to go and buy something and rack it, right? You can just kind of provision it. Less downtime. Move from hypervisor to hypervisor easily here. Scalable. Yes, you can take an image of a virtual machine and then replicate it, or you have like scale sets and things like that. So scale horizontally or vertically. And security. Protects the host operating system when running questionable software, right? Also with all these kind of like go together because, you know, if you have some sort of vulnerability with one virtual machine, grab the image, kind of like provision another one, move over your application, and then, you know, if you have some sort of error or something like that, right? But yeah, those are a couple of reasons why you would want to use them. In terms of connecting to a virtual machine, we have actually a couple of options. Username or password. This is mainly used in like development, sort of like small. I don't even want to say small. I would say things that you're just testing in development, because usernames and passwords can be, everything can be hacked, right? But then you have things like SSH, which is ideally SSH with a key pair. Key pairs are files that you'll need to connect that needs to be on your local machine or where you're connecting from and on the virtual machine that you're connecting to. So having a key pair, it's like a more secure way than using a username and password. And then SSH works over SSH stands for Secure Shell. And it works over port 22, right? We have RDP. If you're a Windows admin or if you've worked with Windows virtual machines, you're familiar with RDP. I think it stands for Remote Desktop Protocol, right? Let me know in the chat if that's right. I'm pretty sure that's right. WinRM. I don't think I've ever used WinRM, but it's also another option. And then Azure Bastion. Azure Bastion is actually pretty cool. I used it back when I worked in an Azure shop. And it's right from the portal. You can just access your virtual machine, and it's secure and set up for you. It's not free, but it's another option too. All right. Let's talk about what is a hypervisor. Hypervisor is technology that enables virtualization to be a thing, right? So software that integrates the physical hardware and the VMs, so the virtual hardware, the VMs virtual hardware, right? And we have sort of two types. We have type 1, which is bare metal. So these are what you can think of like your dedicated virtual machines, not your laptop, right? Or your PC or whatever, not your personal machine or your local machine, right? Runs directly on the host to manage guest operating systems. And most common in data centers, yes. So for example, Azure, Google, or AWS, they will have these bare metal machines, and then you'll have VMs on top of them, right? And then, for example, for hypervisor, we have Hyper-V, Microsoft's Hyper-V, VMware, vSphere, KVM is inside of the Linux kernel. So like some of the popular ones, right? Then you have type 2, hosted. Runs on a conventional OS as a software layer or application. This is something that if you're learning on your own, you probably have used, right? And abstracts the guest OS from the host OS. And most common with individual use, like I said, if you're doing this on your own. For example, VM Workstation, VirtualBox. I know there's like Parallels. There might be a couple other ones. If you know any more, let us know in the chat. But there are a bunch of them up there. So this is sort of a diagram of what a like VM would look like. So we see on the left side, we have server, host OS, hypervisor, and then you can have a bunch of guest operating systems and such in this virtual machine over here, right? And then we have another option over here as well. Virtualizations, we have physical server, right? So this is what would be the bare metal option. You have the actual physical server, then you have the virtualized version on it, and then a bunch of more VMs on top of it. And it looks like this one has shared storage. All right, cool. Speaking about storage, I meant in the agenda, I don't think we had the little bullet point there for storage, but we're talking about storage a little bit here. So we have a couple of options when it comes to storage. We have file storage, which is written to disks in an orderly pattern, much like your current computer. Then we have object storage. So if you've definitely heard of object storage if you've been learning cloud computing or like some sort of platform. I know AWS has S3, Azure has blob storage, but files broken into pieces and stored across systems. So think about media files. Probably the most popular, maybe the most popular storage option when it comes to cloud computing services. But yes, object storage. And then we have block storage, written to and accessed from storage blocks, decoupled from data source. I think block storage is popular for things like logs. I believe so. Yep. And then we have storage types. We have directly attached storage. I had no idea that DAS stand for this. But yes, DAS, directly attached storage, attached to the host machine. Liam has included these little dollar signs as in terms of like how much they cost, which I thought was a pretty neat little thing that he added here. See? Network attached storage, NAS, also very popular. Part of the network delivering file access, part of the network delivering file access across multiple hosts. And then we have $2 signs here. And then we have storage area network, SAN, dedicated high performance storage system. Then we have $3 signs there, right? So we have a diagram here explaining all the storage options. We have the one directly attached here. And then we have a NAS that is connected via LAN or WAN to a bunch of servers. And then we have a SAN that's connected over. The servers are LAN and WAN, and then we have a SAN there as well, right? So these are the three options when it comes to storage types. I guess 3 types when it comes to storage types, right? VMs versus containers. I know Liam is a big fan of containers. I've recently been dabbling with them. We did a bunch of stuff in February about containers and such. But usually when you, like, these days people will say like, oh, you got to run everything on containers. No, virtual machines, kind of like old school technology. No, but they are very similar at a high level. VM is hardware virtualization, and then we have containers, which is OS virtualization. We have namespace, C groups, and such. We have like sort of a difference of a bare metal hypervisor, and then we have a hosted hypervisor, so virtual machines, and then we have what a container would look like when you have the, I guess, applications, right? So we all have infrastructure, and then for the container, we have host operating system. For the hosted hypervisor, we have host operating system. And then for the bare metal version, we have the hypervisor, right? Then we have a guest OS level. And then on the hosted hypervisor, we have a hypervisor, then the host operating system, hypervisor, then the guest OS. And then the infrastructure part of the container part, we got infrastructure, host operating system, and then container engine. So there's no individual guest OS there. So we're saving space. It's more efficient and those kinds of things, right? And then your apps are, again, individual, right? Just like, with virtual machines as well, but there's no guest OS, right? We're going to demo already? Goodness. Anyway, last thing I wanted to say with these is containers are very popular because they're pretty, easy to like pass along, to like, bring up. They have this analogy that's like, I think it's like pet versus cattle, like kind of concept. Whereas like your VM back in the day used to take care of it, like, oh, this is my pet, I gotta make sure it's up to date. It's not necessarily like something that you provision and destroy right away. Whereas containers are meant to be like provision, destroy, that kind of thing, right? So that's the difference there. Very quick overview of VMs versus containers. How are we doing with time? All right, cool. Demo, yes. So for a recap for what we did last episode, we wrote the Bicep code, the Bicep template, and things like that. We didn't get it deployed, but we're going to do that today. We were working on, so the Bicep template had VNets, 2 VMs, 2 network interfaces, public subnet, private subnet, and a network security group, so 1 for each subnet. And then we deployed. This is what we're going to deploy today, right? And then Liam is going to give us an overview of what we're going to do in his part of the demo today as well.
Yes, thank you, Gwen. So after we have deployed that network, what we're going to do is we're going to SSH into the virtual machines. We're going to go into virtual machine number 1. We're going to install an Apache server. We're going to modify some security groups so that I can access it from the internet, my machine. And then I'm going to create and host a web page for you so we can see that all working. And then if we get time, I'll show something else as well. That'll be a surprise. I don't want to say it in case we don't get there. But yeah, this is the crux of today's demo.
Cool. All right. So I think, hold on a second. Let's go back to this full camera, and then I'll bring up, because I'm going to deploy my part of it, of things that we didn't get to deploy last time. So we'll do a add screen here. Which one is it? This one here. Alrighty, cool. Let me make this larger. So last time we were having audio issues, so I didn't get to deploy it. So right now what I'm going to do is just do an AZ group create a new resource group. I'm going to call this, I don't know, Vnet demo 2 resource group. I don't know. Location East US 2. And this Bicep template is the same one from the GitHub repository that we shared last time. Nothing has changed there. So now we just do AZ deployment, and then we provide Vnet. What did I call this? Vnet
2.
Vnet demo 2 resource group. Is that what I called it?
Yeah, I think so.
Oh my goodness, that might be the same name. Hold on. You know what? Let's do this. Let me clear this out. Let's create one that's not something that I had already created, because I was running into issues with like naming things, and like this is something Liam brought up. He's like, "Why don't you try changing the name?" I was like, "Okay, that makes." I don't know why it works, but it works. We'll do create -g. We'll do I don't know, Reactor demo Vnet resource group, and then location East US 2. I'm gonna copy this, because if not, I forgot the R here. If not, I'm gonna forget what it's called. Reactor demo. All right, copy this, and then we'll run that, and then we'll clear this, and then we'll do AZ. I think it's AZ deployment now. No, come on, AZ deployment create, fantastic, and then I'll just paste in the right value for the resource group, and then we'll run that. I'm providing the parameters for this deployment in this file that's called Azure deploy.parameters.json. So that's why it's just going to run. It's not going to ask me anything. I have to bring up my portal though. So 1 second. Let's go back here because I don't know what I don't want to show anything I'm not supposed to. But here, let's go open this here. And then we'll go back here. Fantastic. We called it, what do we call it? Like Reactor demo something? Yeah, Reactor demo Vnet right here. So everything is going to start to deploy here once it is finished. It's still running. Oh, come on. See, we ran into naming thing.
Another one.
It could have been, you know what it is? Let's do VM. Can we put dashes in VM names? Do you know?
Yeah.
So if we do this, it should be fine, right? All right. We'll try this once more. If not,
if not, it's all good.
No, it's all good because we do have infrastructure deployed. I just really wanted to show you the in actual action and live. Easy deployment. Oh, come on. I keep hitting tab when I'm supposed to hit the up arrow. Easy deployment up. And then we'll do this. Paste this. Fantastic. Yeah, what's weird is it'll like load everything here. And then it fails for some reason. But okay, we'll try this now. Did I save it? Is he demo? Okay, cool. But yeah, where is the Azure deploy parameter file from? It's in here. So it's in our local. So this is the same directory that everything is in. And it's right here. There's like there might be some values in there that I don't want to show. So I'm not showing it. But it's there. And that's usually how you would provide your parameters. Sometimes you have to provide them via the command line or something like that. But yeah,
we also have keyboard as well, so you can use key rotation, obviously in Azure, right? So you can store them up there.
Yeah, and provide the URI of the key. So let me go here, refresh this one. We called it Reactor demo Vnet. I have to clean up my resource groups today. Okay, I think it's gonna work this time because it's not failing anything. Go here. Perfect. There we go. No errors. And then if we go refresh, we see we have everything here. We have our demo VM1, VM2, and subnets, the NICs, and there we go. Liam,
awesome. Nice one, Gwen. Thank you. So yeah, that nicely wraps up what we had last week. Really well, actually. And in case that this was going to fail, we did already set up this infrastructure aside from that. So the naming you're going to see is very similar, right? Very similar to what you just did, except it's just called VM1, VM2. So I'm going to share my screen now, and I'm going to show you how you can get inside these VMs. Now, while you were doing that presentation, I actually got kicked out of here. And I'll be surprised if this now works. I hope it does. There we go. Fantastic. So what I can do is I'm going to move you over to the side. Okay, so can we all see my screen? Let me just zoom in, make this big. Alrighty. So here we can see the two virtual machines. You've got virtual machine 1 and virtual machine number 2. And these are running, essentially. So they're up and running. They're in the cloud, but you can't hit them yet. So if I tried to go to one, it would just fail. So let's go have a little look inside them and let's just check out what's going on. So we can see in here, it's running. It's in the location East US. Probably not great for me because I'm in London, but since this is in Gwen's directory, it's over on the East Coast of the US. We've got a public IP address, which is actually dynamic. So every time this restarts, then it's just going to change. You'd use a static IP address usually if you're dealing with something like a Raspberry Pi in your home network. Maybe if you're doing like an ad blocker or something, if your Raspberry Pi restarts and you have to go and access it, bit of a pain if it's a dynamic IP address. So that's when you'd assign a static one. But because these are virtual machines, we don't really care. Okay, we just want to leave them as dynamic. It frees it up afterwards anyway, or when it's not running essentially, which is really, really good. What Gwen has actually done for me is set up a DNS name. So we're going to ignore this for 5 minutes. DNS, if you watched one of my previous streams, I think it was a couple of weeks ago, around domain names, then I explained all about DNS. But essentially, this is what translates to the IP address of the machine. So the DNS name here translates to 20.22.239.253. So when you go and hit that, it will just go off and sort itself with its routing tables, etc. In here, we can see we've got a private IP address and a public IP address in the network. And again, it's part of the subnet number 1. Remember, from that infrastructure, we've got 2 subnets. we are running Ubuntu server. Oh, you've got 18.4. Lovely. So there is 20.04 out as well now, I believe. But yeah, this is a good stable one to be using as well. And this just goes on and just shows the size. Everything that was in that Bicep file is actually translated to the portal, which you can see pretty nicely. So if we go back to virtual machines and go and have a look at number 2. Now, if you remember from that diagram, virtual machine number 2 was actually in a private subnet. Now, we can see straight away there's a difference here. We don't have a DS name and we do not have a public IP address. We can't access this from the outside world regardless. So as you can see here, yep, so 10.1.1.4 is the private IP address. This can only be accessed from within its network. So what we're going to do is I'm going to go and put SSH into, or secure shell into virtual machine number 1. So if I go and copy this one to my clipboard and open up a terminal. So hopefully you can see this okay. Let me just zoom in a little bit more. So to do that, I already have, well, I have half a command ready. So it's SSH is going to be the username. So once you set up the virtual machine, we use username and password. And I just need to put in the IP address. And that's going to ask me for the password that was sort of associated with the key. So the public and private key when they were all set up and the username, it's all kind of tied together. There was a password that was set. Now, I'm not going to tell you what that password was. Otherwise, you'd be able to get in. But straight away, you can see that I've managed to get into that virtual machine pretty easily. Let me just bring this up. So it's covering that little box at the bottom. There we go. It's a bit better. Hopefully, you can see that, right? So awesome. If I do an ls, or rather a pwd, I can see that I am in home/vnet domain or demo admin. Sorry. So that's all wonderful. But what can I do with it, right? If I try and hit this IP address, I'm not going to be able to see anything. So it's just going to not do anything at all. It hangs. You know, it might try and access it, but it just hangs. So let's go and add a policy. So I'm going to go and add a network policy, which will allow port 80 to hit this. Okay. So to do that, I need to go to, and with it being so big, I need to go to networking over here. And as you can see, I've got port 22. So it's priority 1000. So the lower the number in priority, the higher priority it takes essentially. So we've got ports 22 and SSH. I can SSH into it, but I want to add an inbound rule. Now the inbound rule is going to allow me to hit this from the outside world. It's going to open this up to the internet. And I'm going to say I want, God, it's a bit harder seeing it like this, isn't it? I want HTTP. It's right at the top. And that's going to be on port 80. And I'm just going to allow anybody through. Right at this point, I'm saying priority 1010. And I'll give it a name, and I can leave it at port 8080 and give it a description if I want, but I'm not too bothered. So I'm going to add that in. So that's going to allow the traffic from the outside world hit. And I don't know if you saw that, but on my other tab, that went straight from Google to them being able to hit that IP address. But it can't reach anything. It still fails. It's just going to hang, right? So although we can hit the virtual machine, it doesn't have anything on it. So that leads me to my next step as to where I am then going to install Apache. So I'm going to install a web server. Okay, so if I go and grab, I've got a number of commands that I'm going to run over here. So let's go and let's put a password in. I'm going to update. So this is something that you always want to do in virtual machines. You want to use the package manager to update anything that's going on there. And hopefully that's not going to hang too badly. There we go. Lovely. Then I'm going to go and install Apache. That one. And these commands can be found on the internet. I mean, I can include them as well. I can send them through. But again, probably you can just watch this recording and pause it, I guess. But they're just sudo commands. Simply just going off to get a package, just like you would do maybe like a brew install on a Mac, or I don't even know what Windows uses it, chocolate, I think. Maybe if that's the thing. And now I'm just going to go check out and see if I can actually see it running. So I've installed Apache, see what the status is. It's up and running. And I can see that because, well, the information tells me here, all right? So it started the Apache HTTP server, and that's all good to go. Oh, and because I am doesn't want to do anything. Okay, so my terminal's like hanging a little bit. There we go. Lovely. So now if I go and hit that IP address, you may have already seen it. It's already updated. So we can now see on that IP address of virtual machine number 1, we've got an Apache 2 Ubuntu default page, right? And it's telling me right here, if I'm seeing this, it's wonderful, it's working properly, or if you're expecting some big organization, when you hit this address, then you've probably got a problem. So to replace this, I need to go into the server, and this is where the SSH command, or this is where sort of jumping in and modifying the files is really good. It's really telling me where to go. So if I go to the file, www.html index.html file, it's all going to be there. And this is where this is built from. So if this is kind of like a bit, but it's good fun. So if I jump out of where I currently am and I go into, let's go var www. Let's just have a look in here. What's in this folder here? So I can see a HTML file. So this is all being created for me from Apache. If I go into the HTML file and I do an ls, I can see the index.html file. And if I cat that out, I should see all the HTML of that lovely Apache homepage. But what I'm going to do, let's just ignore you for a few seconds. What I'm going to do is I'm going to do a sudo remove. I'm just going to remove the index.html because I can't be bothered to keep that one. I'm then going to go and create another one myself because this is just easier to do it this way. And I am forgetting to do a touch there. So if I was to cat that out now, it's blank. So if I go into that one now and have a little look, hopefully, there we go, it's blank. Awesome. So what I've actually written, I've created a little splash page that I want to start creating my server with. And it's over here on GitHub. And this is just a quick HTML splash screen, but it looks kind of cool. And I like it. So let's go and copy and paste that into this file. And paste. Cool. And if I exit that, so let's do a write and a quit. Did I do? Okay, were you watching, Gwen? Did I do a sudo? I did not do a sudo. This always catches me out. I don't have sudo rules here. So let's do that one again. So jump into there and let's paste in that code. So now I've gone sudo. I have the rights to write and quit that file. And if I was to cat that out, it would be there again, but I'm not going to bother. I'm just going to go straight to the web page and hopefully, with a bit of luck, it's updated. Awesome. So now I've got my own splash screen. And that's simply how quick it is to jump into a virtual machine, start creating files. You can copy and paste them. You can set these up from the beginning. And we do actually have time because it's only 1:30. So I'm going to show you now how to get into virtual machine number 2. Because if you were looking, we don't have any of these rules on virtual machine number 2. We have only got the bare basics. We've got a private IP address. This is all hidden, right? This is all hidden away in the architecture in a private subnet for everybody. Again, so here's subnet number 2, virtual machine is in subnet number 1. So if I was to click on networking, I should see like there's absolutely, I don't want anybody touching this. And in your private subnet is usually where your private data is stored. So things like databases or servers that run many databases. So if you think about a storage area network, that would all be hidden away, right? You don't want anybody to touch that. So what we did when we created this one, we actually set up a user. So if you actually want to get into your database or modify things, update it, you can do that. But there's kind of like a chain of a proxy that you have to go through. So if I come out of this one, let's just go back to my home directory and let's clear that. My terminal is still complaining. I can do exactly what I've just done, but with a private IP address from virtual machine number 1. So virtual machine number 1 is a public facing, and I can use that as kind of like a proxy to get through to virtual machine number 2. So let's go and find the IP address for this one and just copy that one. Because they can talk to each other, right? They're in the same resource group. They're in the same network, the same virtual network. I think it's just VM2 at that IP address. And it's going to be the same password. And that's just because I set it up. You can actually do this all in the portal. But I'm using the same password. And from VM number 1, and of course, talking and typing is always a good fun. So I got into this through virtual machine number 1. Virtual machine number 2 is all hidden. I can't hit this from the outside world, but I can if I go through virtual machine number 1, all within the same virtual network, just different subnets, same secure, same resource group. And in the next one, I'm going to be showing you, so like the next episode, I'm going to show you all how you can separate all of this with security groups, because we've already added one rule, but that rule is terrible. Everybody can answer, or anybody can get that. In fact, I mean, Gwen, feel free to go and ping this IP address, or I guess anybody on the stream. I'll leave it live for a little bit, but I don't want it to go overload. That'll cost us an arm and a leg, or just crash, one or the other. But yeah, if you want to go hit that one and go click for a surprise, I'm not going to ruin that for you. Feel free. So anybody on the stream, please do go and have a look at this one. The IP address is 20.22.239.253. And go click for a surprise and go try our Cloud Skills Challenge. So that is step number 1 and step number 2 of this demo. And because we've got time, I'm actually going to show you something else that's really cool. Because you may be sat there thinking, Liam, that's really, really annoying. I have to go through so many steps just to deploy a simple HTML web page. Well, no, you don't. You really don't. And there's 2 things with virtual machines, which is really cool. Similar to containers, if you think about it. Now, I know, Gwen, you said I like containers, and I'm not going to preach about them here. But when you create a Docker file for a container, you're essentially giving it steps of deployment. So when you spin that up in its kind of virtual environment, you're giving it steps to run through. You give it a base image, you're giving it commands to run to install certain packages. So if you think about everything on Docker Hub, or in any of the sort of registries, they've all got a base. You're telling the base, you're giving them commands. They've installed certain packages. So a Go image is going to have all of the Go packages associated with it. All the Node images are going to have like the Node packages associated with it. Just same, just different packages installed, right? And different image. Same can happen with virtual machines. When you're setting up a virtual machine, you can actually give it scripts, and it's called a cloud init script. It's cloud agnostic. This is done whilst it's provisioning, or this is executed whilst it's actually provisioning. And it's the same whether you're working in AWS, in EC2 instances, whether you're in GCP, whether you're in Azure. It's pretty much the same. They may call it something different, but it's all the same. You give it a script, it will run some commands and install some things for you. And then you have user data, which is very similar. It's almost too similar to really go on about. But again, it's just like a script or a bunch of commands that you can give a virtual machine, and it will do certain actions for you. And I'm going to show you how to do that. So here I am in my directory. So let's just reload to make sure that that has not lost it. I'm going to zoom out a little bit just to make it a bit easier for myself. And I'll show you how I'm going to do it. So if I create a virtual machine in Azure, and what I'm actually going to do is I'm going to turn my mask on because I have some personal data on here, which I don't want you to see. And I'm going to go through this. And this is what you do in the portal. Of course, you can do this all from the command line as well. But I'm going to stick a new virtual machine. I'm going to put it in my virtual networking series. I'm going to say Vnet series demo machine. And here we are. It's just complaining it some naming. Again, I'm going to put it in UK South. It makes sense to me. I'm not going to spend too long with this. I'm just going to whiz through it for you. Very basic. Now I'm going to have SSH public key. So we use password on the other one, but I'm going to use public key. And I'm just going to say the username is Liam. So like when I logged in, I used, I can't remember what I did. Username was, what was it? Vnet demo admin or VM2. This is just going to be Liam. So I already have a key pair. And I'm going to use a existing public key. Now this is what I don't want you to see. And hopefully this mask will hide it from you. So there's just a little command which will allow me to copy this to my clipboard on my actual machine. Wonderful. And hopefully the mask did not hide that from you, but it's fine. It's not big enough. Anyway, I'm going to allow some SSH port again so I can jump into it with my terminal. If I wanted to add disk or networking, I don't really, I don't want to, I don't care. I just want to put this as a standard SSD. I don't want to be charged too much. This is just going to be an example for you. I'm going to delete the virtual machine once, when I delete it. The encryption type is going to stay the same. All of this stuff. You can add loads of disks. You can add networking. Here, I can add my security groups if I want to. I'm just not going to bother. I can do that in a minute. Again, so many options you have if you're doing this through the portal. But again, everything's available through the command line too, if you're into that kind of stuff. yeah, I'm going to delete the network interface card and the IP address once I delete it. And of course, I forgot to mention actually load balancing. Now, load balancing is a really, really handy tool. And I guess we can probably talk about that a little bit more with security groups next week. But essentially, if I had multiple machines in my public subnet running the same websites, like you all might be bombarding this website for me right now, I may have multiple machines running the same thing. How do I distribute the traffic equally across them so that one doesn't completely crash and leave it sort of like downtime and sort of burden the network as such? And you'd use that with a load balancer. And a load balancer would be a single point of entry into the network, which you just hit one IP address, and that one IP would then spread out to the associated resources attached to it. So that's in short what a load balancer does. I'm not going to bother with this one because I don't need it. Yes, I can say that my subscription is all wonderful. I don't need to worry about any of that. For some reason, my mask is not working, but we will ignore. I don't think I need anything else. Here we are, custom data. So this is what I was talking about. So this is a Cloud Init script. And what I've actually got for you all now is a simple Cloud Init script. Now, hopefully you can see this if I zoom in a little bit. And I'll run through this pretty quickly. So this is going to install some packages. It's just a YAML file. So we've got an Nginx server. We're going to install Node.js and NPM. So what you generally do if you're going to be creating a Node app. We're going to create some files. Now, this one is a little bit, you probably wouldn't write this one, but this is an Nginx default file. And this just tells you where the server's listening, any proxies that it's going to go through. So, to get rid of the cause errors that you might come across. You're going to be looking at who the host is, the keeper life, so the TTL, or time to live for certain connections. So if I make a request, when's it going to drop? Things like that. You're not really going to write that one, but we need to for this. And then the second file, and again, the owner for this one is the Azure user, aka me. And I'm going to give it a path. And what you can see here, it's in my home. It's in Azure user, aka whoever I am. It's going to be called my app, and index.js is simply just a file that I want to run. You may call that something else, node.js or something, I don't know what other people do. Server.js, that's the one. I'm a Go developer. Don't come after me. I don't write Node. Well, unless we're here. So a really simple small server that we've got. So this Express is going to pull in the required modules that we've installed. It's then going to just give you like a simple hello world from the host. And this brings me into the next point that I want to mention. You can grab host names and IP addresses and all sorts. And this is a really good demo to show when you're looking at load balancing. So if I can, I'll probably knock something up for next week to show you how the load balancer might work in this instance. But you can spit out, hey, this is virtual machine number 1. And I don't know, Gwen might make a request and it may say, hey, this is virtual machine number 2, for example, but you're hitting the same IP address. And it kind of helps you understand a little bit more how that works. And again, as you would with any Node application, or I guess any HTTP server, you spit out and say, hey, I'm listening on port, whatever it is. In this instance, it's port 3000. And then it's just going to log something to the console so that it does something. The final part of this is the run cmd command. And this is essentially a terminal. This is just the commands that it's going to run inside the virtual machine whilst it spins up. And it's going to run the Nginx restart. So it's already created it. It's just going to restart it and load up what we have in there. It's going to go into the directory. So home Azure user / my app. And then it's going to run what you'd run on your normal machine. So i.e. your PC. npm init to pull down all of the modules. npm install to install them all. Or I say npm init, it's actually going to initialize the project. Sorry, the install is going to pull down and make sure everything's on this machine for you. And then, of course, it's going to run it. And it's just going to run that with the run script Node.js index.js because that's where it is. So a really simple script. And this is just simply going to spit something out to a web page, hopefully. So if I copy this and drop it into this custom data field without anything, we get that lovely little tick over here in the corner saying that, yeah, that is A-OK. It can recognize this is YAML and it looks good to go. What I can then do is we don't need to enable user data. Like I said, that's actually something very similar. But again, here it just says passing in a script. And this is available throughout the lifetime of the virtual machine. Don't need to do that. Yeah, actually, that should be in bold here. This bit here, don't use user data for storing your secrets or passwords. That should be in bold. Because, yeah, you definitely don't want to do that at all. Again, you can just have like loads of little things that go on in here. But we're just going to go ahead and create it. So it's going to go yada, yada, yada. It tells me it's going to be really, really cheap to run. Let's go and create. I'm not going to scroll down because I know there's personal data there and this mask is not working. But essentially, this is going to go off and create all these little resources that we have. So I guess security group, network interface cards, virtual machine. It's all going to sort of deploy that for me. And it's going to spit out here in a minute once it's finished doing its thing. There we go. It's going to show you sort of the progress of it. And I find this really cool because you can actually get to this very point and start downloading templates for automation. Again, here, so the deployment details, I can download all of them, what I've done to get to this point, essentially. And awesome, that has deployed. But if I click on go to resource, it's probably going to give me an error saying it's not ready. Yeah, cool. So we can troubleshoot this, but we're not going to bother. I know that I've given it a script. Therefore, I can assume it's going to take a bit of time for it to start up and do whatever it needs to do to load or build whatever we need to build, right? So I'm going to give that a moment. And I guess now's probably a good time to maybe answer some questions because this might take a couple of seconds.
Yeah, we have this one here that I felt like could take a few minutes to answer. So do we consider the load balancer as the gateway into our public VPC or VNet in this case, then get into the private VPCs through the public? Okay, so I think so VPC is AWS, right? That's what the terminology they use?
Yeah, VPC is AWS. In Azure, we use Vnet. It's pretty much the same. So cloud computing, I find this quite amazing. Cloud computing has got all the same fundamental concepts. Everybody calls them different things. So when it comes to doing certifications, it takes me time to think about whether that's AWS, whether it's Google, whether it's Azure, and so forth. So we all call them different things. But yeah, in answer to your question, the load balancer should always be a single point of entry to your network. And that is because if you end up with a load of traffic hitting individual virtual machines, you're going to bring them down. Like it's just not going to be able to withstand that amount of traffic. Whereas a load balancer, think of it as like an hourglass. Everything comes in from the top, hits the load balancer, and the load balancer then distributes it out at the bottom across the resources. And yeah, if you're trying to get into the private subnet of your VPC or of your VNet rather, then yeah, you could use this as a proxy. Sometimes you may have a direct link in and you may have a complete specific route set up. So if you remember, I think last time I may have spoke about it, maybe like a point to site, you may have like a complete direct link into a private virtual machine. You could set that up with your own network gateway. It may just be like a backdoor essentially. Maybe like a VPN or something into that to help it. But this is very much where security groups and all of security around networking starts to come to fruition here. Because yeah, you don't really want to be able to get, through your public subnet straight into your private subnet as easy as I just did. And I've done that to prove a point so that it's possible. But this is where you got to be really careful with your security groups and what traffic you allow in. And we'll probably go into much more detail next week on that one.
Yeah. Also, I guess load balancers, you wouldn't really have them take public traffic straight into like your private subnets either.
Oh, no, definitely not. That always goes to your public. So it always goes to public resources. Like I said, unless you've got like a route table, right, for that specific machine.
Yeah, and then we have a couple of people who found the surprise. It's a nice surprise. Never going to give you up. Fantastic.
Brilliant.
Let me see if I missed any other questions.
I'm just waiting for this still to come up. I'm going to leave my screen sharing because hopefully this should just pop up at some point. It might error out to begin with. It may time out, but not to worry. This should still work. Fingers crossed.
Totally fine. Let's see here. I didn't know TTL stands for time to live.
Yeah, time to live. You have it on cache. Yeah, you have it on cache and things like that in the browser. So your cache will have like a TTL of maybe like a week or something. Well, it depends how really bad you want to keep your data around, right?
Yeah. And no, surprisingly, we have a comment about Nano. Nano is just so much more intuitive, but then you see the Vim jockeys doing stuff at light speed, and yeah, mice are overrated.
I tell you what I forgot to do. I actually forgot to put my inbound port to port 80. So that's always going to fail. Here we go. I knew I forgot something. Yeah, very much the same as what I did prior to this. Let me just pop in the service to be HTTP wherever we are. It's right at the top. There we go. It's just on something that is so zoomed in. Again, priority 310, 300 is high priority. Want it to work. So we're going to add that route in. And then I actually think it's been enough time for this to have installed everything.
Yeah.
I think that'll be really good to go then. So wait for this to do its thing in Azure. There you go. Created the security rule. Hopefully, give it a second to refresh. And moment of truth, everybody. There we go. It worked. So this is hello world from the host Vnet series demo machine. So that is the host name of the machine. And like I said, you can get IP addresses, you can get all sorts of things. It's just code. You can do whatever you like. It's a virtual machine, very much like your desktop, just in a little box packaged away somewhere on someone else's server. But yeah, that's how you do cloud init scripts. That is how we create automation. And this is actually a really good time to mention automation, because this is how you would do it in maybe a production system inside a pipeline, whether that's, I don't know, whether you're using Jenkins or Travis CI or, I don't know, GitHub Actions, I don't know, maybe even Azure pipelines, right?
Yeah.
So this is the kind of way that you would navigate automation with a virtual machine and update it periodically. You pass in scripts. You probably wouldn't write the code out like I have in this file here. You'd probably just point to like a different repository with a script in it, or like kind of bring it in, clone it, if you get what I mean. But yeah, that's an awesome way to show automation, and I'm actually really glad I managed to squeeze all of that in.
Yeah, we got a lot done in this demo. We switch over to the episode recap. Right, we covered what a virtual machine. We'll cover some theory in the slides. Virtual machine, hypervisor, how, why it's used, VMs and containers different, and then we did all the stuff that Liam covered in the demo: how to connect and work within a virtual machine, the private one, all that kind of good stuff. Oh, we wanted to just remind you all about the Cloud Skills Challenge. Do we have links? If we can drop links to the Cloud Skills Challenge in the chat, that'd be awesome. There's already 250 people participating, which is fantastic. We still got plenty of vouchers to go away, so do make sure you get in there. Perfect. We've just added them to the chat. We have like, I can't remember, I think it's like 9 or 10 modules in there covering stuff from networking and Bicep, which is the focus of this series. And if you are within the first, did we say 30 people?
I think it's 30, between 30 and 50.
I think we said either 30 or 50. I can't remember.
Yeah.
And the first ones to reach out once they've completed and been able to verify that you've completed it. We're giving vouchers 100% off the AZ 700 certification. So that's the link. Yeah. That's a good amount of money. Well, I mean, voucher. It's not money, but like the cost of the voucher, right? And yeah, like connect with us, Twitter, LinkedIn. Our Twitter's on like the bottom left. You can see them. And then you got to share your MS Learn profile link and screenshot of it to show us that it is complete. Again, that is the link to the Cloud Skills Challenge there. And that is it for this. We can start answering questions and such. But here are all the ways that you can connect with us on socials, Twitter, LinkedIn, on me, and YouTube.
Awesome. Yeah. Fantastic. I think on that slide there might be a little bit of, I don't know what I'm seeing. There might be a bit of a ski whiff stuff, and the YouTube thing's black instead of red. But hey, we run with it.
I'm on the online version. That might be why.
Yeah, quite possibly actually. Alrighty, so should we take some questions?
Let's take some questions. What do we got? Let's see. Any questions, anyone? We have a thank you. Thank you guys so much. Appreciate the lesson. Looking forward to next lesson. Yeah, we're doing some security stuff, right?
Yeah.
Let me see. Here we go. I don't know if you answered this. So do you run your automation scripts inside the public VNet?
I ran the automation script. So do you run your automation scripts inside your public VNet? I presume you mean the cloud init script, and that's actually on the virtual machine itself. So as it's provisioning, it knows to go through and sort of pick up anything that it will check as it's being provisioned, whether there's anything that's been inputted or not. And that's going to be a user data, custom data, basically a cloud init script. And if you mean, do you run your automation scripts inside the public VNet? You would probably run this externally. That will then feed into your public or your virtual network, essentially. So if you have like a pipeline in Jenkins, like I said, that would then just feed into a virtual machine via IP, via SSH or something like that. And then it'll be able to deploy, modify, update things. as you go. So I hope that kind of means answers what you mean. Sorry.
Yeah. I think that's all the questions. We didn't get too many today. More just people thinking and hanging out with us. We're right on time too. If you have any questions, last minute ones, let us know. But if not, we could probably, Sam just says, excellent. Thank you.
Most welcome. It's great to have you all here. It's been a fantastic session. And yeah, we are bang on time.
Everything worked out.
Exactly. It worked this time.
My throat didn't give out either. So
fantastic. You sound so much better. It's great to have you here. It's great to be doing this session still. And next week we're going to be doing security groups. Going to be playing around with sort of different traffic accessing different parts of the network and how that really works. Because I know today I only really showed you how you get into virtual machine number 2 from virtual machine number 1. But I guess that's kind of a little bit boring because, jumping in, jumping out, right? So maybe we can show you a little bit more around that in the hands-on.
Absolutely. All right, I think we wrap it up. Everyone's saying thank you. A bunch of thank yous in there. Glad to see you're feeling better, Gwen. Thank you so much. It should be much better by the next week too. All right, should we call it?
Yeah, let's call it. Have a good Easter and a long weekend, everybody.
Bye, everyone.